Quantities. There are two types of quantities, scalar quantity and a vector quantity. Cartesian vectors. The coordinate plane system was invented by René Descartes. The coordinate plane is sometimes called the Cartesian plane in his honor. The Cartesian plane exists in both positive and negative values of x and y. They are divided into four coordinates or sections according to their values. This is a vector. A vector has both magnitude and direction. The length of the line represents the magnitude of the vector, and the arrowhead points the direction of the vector. The most basic thing to do when you have more than one vector is either to add them or subtract them. By adding the two vectors, we get a third vector, the resultant vector.
A formula is applied to calculate the magnitude of vectors in the motion of planes or bolts. The velocity of object observed from the medium is equal to the velocity of object with respect to the medium plus the velocity of the medium. These vector quantities can be determined by using the sine and cosine law. In this example, the plane is flying from one airport to another. The runway is 20 kilometers west and 16 kilometers south from the plane. The resultant vector is obtained by joining the vectors from head to tail. The resultant vector can be found using Pythagoras' theorem. The magnitude of the resultant vector is 4√41 kilometers. In order to find the direction of the motion of the plane, the sine law is used. Sine A over 16 is equal to sine 90 over 4√41. Sine A is then equals to 4√41 over 41. A is equal to the inverse sine 4√41 over 41, which gives us 38.6 degrees. The direction of the resultant vector is in the southwest direction. Therefore, the bearing of the plane is 38.6 degrees south of west.
The dot product is when u dot product v equals to 0. U and v are perpendicular. There are some situations in which dot product can be applied too. Dot product can be used to calculate work done. Another problem where we can use the dot product is finding an angle between two vectors. Also, dot product can be used to find the projection of a vector. The work done can be calculated by using the formula W equal F dot product D. For vector projection, the projection of V on U is the shadow that V casts on U. The angle between two vectors can be found using the formula cosine theta equal to A dot product B over a modulus times B modulus.
Now, the application of cross product. One of the applications of cross product is to find the torque of the wrench. The formula for finding the torque is T is equal to R into F, where R vector and F vector is arranged tail to tail, and R vector is the distance between the center rotation to where the force is applied, and F vector is the force applied. Modulus of T is equal to modulus of R into modulus of F into sine theta, where theta is the angle between the R vector where it is arranged tail to tail, whereby torque, the resultant vector, will be directed inwards or outwards. To determine the direction of the torque vector, we use the right-hand rule. The index finger represents the direction of R, the middle finger shows the direction of the force, and the thumb will show the direction of the torque.
Now, the application of dot product and cross product. The triple scalar product is used to find the volume of parallelepiped. The formula is A dot product B cross product C. The cross product is done first to get a vector quantity. Then, dot product is done to get a scalar quantity, which is the volume. This is an example of the combination of cross product and dot product.
created using Powtoon.